Perfect. So we're group 3. We are Vladimir, Nora, Stephen, Anders, Merve, Maria, Felipe, and Konstantinos. We're going to do the final part of this study case, as we see now in the following. So it is important to understand that what the IP design is and how we see it in this study case, which is a methodology that facilitates the identification of a business model's core elements, always from a customer's point of view, and how those elements can be eventually protected via IP. We'll see how in this presentation, this IP design methodology can be applied to the example of the electromobile ecosystem. So this electromobile ecosystem includes many elements, such as the vehicles, power supply, and transport infrastructure. And all of these elements need to be networked and interlinked to enable sustainable mobility, which is the purpose of the business. But the important matter here is that the focus should always be put on the users themselves and what their mobility needs are. We're going to explain here how 3 different framework or scenarios can be put together to form this IP design. We have the AIOU method, which includes 5 different elements in a, let's say, holistic approach. These 5 elements are activities, so which are the actions and behaviors that the users are taking to reach certain goals. We have the environment, what is the overall setting in which these activities are taking place. We also need to take care of the interactions, what are the basic interactions occurring for the users, what are the objects, which are the details that are that form the environment, and of course, a important element of understanding who the users are. And then we also combine it with another framework, which is a cognitive walkthrough, which is a more specific analysis of the whole context, which focus on all the steps that users take when they want to reach a goal in a certain scenario. These 2 frameworks are combined, and we're going to see in the next slides how this method and cognitive walkthrough can be used to analyze the business elements and potential IP opportunities in the electromobile ecosystem. Marvi is going to take us through the next steps.
So cognitive walkthrough is actually an inspection, can be defined as an inspection of a proposed system from the point of view of the end user. So if we were to consider this parking method, a cognitive walkthrough can be something like this. So the user comes and they first select a parking preference. This can be based on the size of the vehicle or the duration of the parking or both. And then they communicate this parking preference and identify themselves upon entering, because as mentioned in the case for hospital, for example, in case of an hospital, the patients will be probably stay shorter, but the employees will be staying longer. So this also differentiates between the parking spot allocated. And then the vehicle enters the garage and they look for the assigned parking spot and they park the vehicle. And then they get feedback for correct parking position and they look for an exit, leave the garage, and do whatever it is that they are supposed to do out of the garage, and then come back for exiting the garage. And this triggers the payment procedure, which is the only thing that is left to leave the garage. And then they look for the parking area, they unpark the vehicle, look for the exit, and verify payment, and then leave the garage. So this is a possible walkthrough of a customized parking experience.
And continuing now with the AIOU framework, as Felipe explained, a framework that is supposed to document findings during consumer research or during usability testing efforts. Here, in the case of our parking space example, the activities are actually quite clear. First of all, there is the guidance, the assigned parking bay, how the consumer who enters the parking space gets to the designated parking bay, then the actual parking, and then the confirmation that the parking was done in an appropriate manner and not so that the car occupies 2 parking lots, for instance. The environment is not so much linked to the physical environment. It's more about the mission that is associated with the activity. And there are basically 2 points. First of all, it needs to be pretty self-explanatory for the driver to find the designated parking place. And then once they park the car, they want to have an acceptable feedback on whether the parking was done in an acceptable manner. The objects listed out here are pretty much known to every one of us who have ever visited a parking place. There is the entry barrier and the exit barrier. In between, you have the signages, you have the lighting system, but you have also the things that we are hardly seeing, for instance, sensors or cameras within the facility. The users here broken down into certain subgroups that are either driven by the gender. So there's a particular user that is defined by gender to find a parking place that is supervised, illuminated enough, and easy to navigate to and from. Then there's also a certain user group that have cars that are bigger than the average car. They call it SUV parkers here, or smaller than the average car, where potentially you could also charge a lower price, as described in our case. And then there are social demographic factors linked to a certain consumer group, consumers that are extremely price sensitive, or let's say average parkers. And last but not least, there's a section on interaction that the driver has in the traditional physical sphere, like for instance with the signages inside the parking space, but also in the digital hemisphere, how the parking guidance system records the movement of the vehicle and feeds back to the driver where to take the car to. And this system, the AIOU framework, now gives us the opportunity to link these activities with the respective the corresponding objects and the interactions. And it all points to NORA now, where we get an overview on how to develop specific IPs to deliver on that framework.
Thank you, Stefan. As a next step, we have to identify the issues that have to be solved by the means of technology that provide the customer best benefit based on the usage case. In this case, it's leveraging maximum willingness to pay for the individual parking preferences. And therefore, we list some examples of non-trivial or unobvious tasks, because at some points, as Merve and also Stefan described, that we need to have this parking preference and the usage for the customer benefit. So there is a need of recording users' parking preferences and evaluating occupancy situation. And maybe it's helpful for some users to have a directing system which helps the users to find the parking bay, or which helps to get perfectly into the parking bay. And another example is ensuring availability of parking space as booked. As Stefan said, there are different types of users, with small cars, with SUVs, or price-sensitive users. And there is also a need for a computing parking fee for this parking space as a booked. And if you take this example, there's a potential environment for generating sustainable uniqueness, which you can also for which you can also use IP. And there's further a need to evaluate and specify this unique environment. And then Andreas will go on.
Yes, so now we have moved from the user and now we're getting closer to the actual core technologies. So we're getting down in hierarchy. So this task that we're beginning in this example of the parking space and park a car. What is the core technology now that we need? And then we have also the alternatives that Benjamin will discuss further on. But if we start with the core alternatives or the core solutions that we think we need from a technology point of view to be able to satisfy the user and the user experience that we're looking for, we have to, first of all, of course, find free parking space. And then the question is, how do we do that? The other one question that also comes in when we have found the free parking space is, can we park our car in it? Is the dimensions of the parking space enough compared to our car? That's the next question that we need to have a technical solution for. Moving on, when we then have identified that, yes, we can park the car in this dimension of the parking space. Okay, have we done it so in a correct way? Or are we off track, or are we on the lines, or whatever? Have we done it as we're supposed to? In that relationship as well, it's also nice to maybe have a marking or some kind of identification so we actually know how and where to park. So we can also assess this on our own. And then if we don't really know or can do it on our own, can we give you some assistance in the parking process? Can we park the car for you? Can we have any type of signaling or other markers to help you in a technology way to park the car? So these are the core technology that we think that we would need to achieve the user experience that we're looking for. And then exactly how to do this is still an open question, and there might be some alternative solutions to this, and that will Brynjar discuss more in detail.
Thank you, Anders. Okay, so to pick up on that, the actual fact might be that as we were guided in the task that the invention course or the actual proposed solutions should be checked against prior art. And looking at the next task, we made the assumption that basically some of these might be also already covered by pre-existing IP rights. That's why we were set out in the next task to proceed with identifying the alternative technical solutions which might be there to serve the same element which was looked for in the first place. So the given elements, so the one which was talking about the variable parking space markings, the given elements was about the space requirements and this display marking. Working on that, we saw that basically we'll start firstly with the space requirements. The space requirements are the ones what are they consisting of? They're consisting of basically the vehicle dimensions. So of course it's a given, but also what's interesting is also the occupancy of the vehicle, and to match that occupancy with the vehicle dimensions, because also that's also important, because it could be certain situations might be that defining the different occupancy might also define and influence what the solution may be. And the second one was the display marking. So basically, how could one mark this particular way? How the parking space should be marked? And there we had basically two lines of drilling down. The first one was optical, and the second one was mechanical. the first one, which was mechanical, that one could go down, also drill down a little bit to have with some physical limitations or bars or ramps or something. Also, perhaps walls could be envisioned to be used for that place. Even curtains of some kind, but that looked a little bit less interesting. But if necessary, that could be a technical solution which might be used as well. And on the other hand, the optical, let's say, ways how this space demarcations could be made, could be by different visions or different versions of a projection system, or by putting on the ground some some lighting elements, or perhaps also some projection from the top of the coming to down to the bottom of the floor. So this could be how this could be tackled. These attributes are something which could be used for that. And finally, another variant of this is instead of using outside elements, so which could be marked on the floor, those one could use within the car, could integrate the solution of integrating internal cars potential existing navigational system to have this kind of navigational guidance into the particular guiding areas, which would be done also from the inside. Potentially also even finally a head-up display could be considered to show exactly what would be the designated parking space. So this goes all to show that a particular, let's say, technical problem could be taken into account to be also solved by alternative ways, if one should take into consideration the potentially existing prior art in terms of other pre-existing patent applications or even granted patents, because we are talking about patents here. Thank you.